This video goes over trig functions translations, so horizontal and vertical shifts. So for vertical translations, if c, this constant at the end, is greater than 0, the graph of y equals sine x or cos x is going to shift up. If c is less than 0, the graph is going to shift down. So the period remains unchanged with a vertical shift. The amplitude or the height of your curve also remains unchanged. That will change with the stretches that we get into next. Your max and your min value are changed by adding or subtracting c. Same thing with your minimum value. The domain remains unchanged, and your range is also going to change because that is connected to your min and your max. Okay, so changes by adding or subtracting c based on whatever you have. So let's take a look at a equation that has a vertical translation. So y equals sine x minus 2. So my period is 2 pi or 360 degrees. That remains unchanged. My amplitude is my amplitude is 1. So the height from the middle of my curve to the top. And then I've got, what else do I have? So my max value, originally it was positive 1, but now I've shifted my graph down 2. So 1 minus 2, now my maximum value is minus 1. My minimum value has also been shifted down 1, so that would be now minus 3 instead of minus 1. My domain is still going to be from minus infinity to positive infinity, and my range now goes in between those maximum and minimum values. Horizontally, we call it a phase shift. So if d is greater than 0, the graph is going to shift to the right. Remember, in the equation, this looks like x minus d. If d is less than 0, the graph is going to shift to the left. In the equation, this looks like x plus d. Going through our characteristics, the period is unchanged because all we're doing is shifting the graph. Amplitude, also unchanged. Our maximum and minimum value, because we're shifting it horizontally, also unchanged. Domain, all x values are still okay, so that remains unchanged. And our range is also unchanged because we haven't shifted up or down, therefore not affecting the maximum and the minimum value. So if we do y equals cosine, let's say x plus 30 degrees, this would be a phase shift left by 30 degrees, but our period is still 2 pi or 360 degrees. Our amplitude, still 1. Max value is still positive 1. Minimum value is negative 1. And then our domain is all the real numbers. And our range just goes between minus 1 and 1. So let's look at a couple of graphing examples. So here we've got some steps to follow as a process for graphing. I also like to sketch my original or parent function, just like we did before. So you do want to include on the midline for your function or the axis of the curve. Then you're going to sketch on the maximum and the minimum lines at your curve value plus the amplitude and your curve value minus the amplitude. Then you're going to use the phase shift to plot the starting point. Then you're going to plot the end point, divide the distance in half, and plot the middle point, and divide each of the sections in half, and then plot the final 2 points. Okay, so let's take a look at this point here. So our base points for our parent function, which is cos x, I would have 0, 1, 90, 0, 180, minus 1, 270, 0, and then I've got 360 and 1. So cosine kind of looks like a cup. I'm going to plot those ones on here now. So 90, 0, 180 minus 1, 270, 0, and then 360, positive 1. And I'll connect those dots, shifting them like this. Okay, this is my parent function, y equals cos x. Next thing I'm going to do is identify my transformation. So I've got a phase shift right by 60 degrees. So I'll change color. Let's use red this time around. So that means that my first point, instead of starting at 0, 1, is going to start at 60, 0. So I've plotted my starting point. I'm also going to plot my ending point here. Okay. Then I'm going to divide that distance in 2, and I'm going to plot my middle point. So I'm moving here. And then on my midline or my axis, which I should draw in, which happens to be here, right at y equals 0, I'm going to plot my next 2 points, right here, and then I'm going to sketch my curve. So the red one that I've drawn, this is my phase shift to the right, x minus 60 degrees. Let's take a look at another example. So y equals sine x minus 3. So right away I'm going to notice 2 things. One, that my parent function is sine x instead of cos x. 2, that I've got a vertical shift down by 3. So my original points for sine x are 0, 0, 91, 180, 0, 270, minus 1, and then 360 and 0. So I'll plot those points. 0, 0, 91, 180, 0, then I've got 270 and minus 1, and then 360 and 0. So sine looks like a snake here. So I've got y equals sine x. Now for my transformed graph, so I'm going to put on my midline first. I know that I've shifted down 3, so that means that my midline, oh yikes, so 2, 3. So my midline is right about here, and I will label that to be y equals minus 3. So then I'm going to move all my points down according to that midline. So I'm going to plot my first point right here, right at 0, minus 3. I'm also going to plot my middle point down 3, and then I'm going to plot my 360 point. Then I'm going to divide those 2 points in half and put on my remaining 2 points. So I've got 91 shifted down 3, should now be at 90 minus 2. And then my minus 1 is going all the way down to minus 4, so I will shift it right down here and connect my dots. And this is y equals sine x minus 3. The last one that we're going to do is a combination. It's got both transformations. So here we're using cos. So my parent function is y equals cos x with those same 5 points as the first one. So 0, 1, 90, 0, 180 minus 1, 270, 0, and 360 up here. I'm going to connect them. Kind of looks like a cup here, and I've got y equals cos x. My 2 transformations are I've got a phase shift left by 45 degrees, and then I've got a vertical shift up by 2. Now there are 2 ways that you can do it. You can move these points around probably, I mean, it's up to you really what the easiest way is. But if I put in all my x coordinates here, so I've got 0, 90, 180, 270, and 360. And I could put in my y's, 1, 0, minus 1, 0, 1. Really what I'm doing is I'm taking x and I'm subtracting 45, and I'm taking y and I'm adding 2. That's going to bring me to a new table of values. So I've got minus 45 and 3. Then I've got 45 and 2. Then I've got 180 minus 45, which is 135. And then I'm adding 2 to my y coordinate, so it would be 1. And then I've got 270 minus 45, which is 225. And I'm adding 2, which is 2. And then my last one, I've got 360 minus 45, which is 315. And then I'm adding 2, so I've got 3. So from that transformation, I can see that my new midline, so I'll do this in red, is going to be at y equals 2. Okay, those correspond to my original midline points at 0. Makes sense. I've shifted my function up 2. So I've got a new midline up here at y equals 2. My first point that I have is at minus 45, and it is at a maximum. So I'm going to have it up, up here. So minus 45 and 3. My next point, which is on the midline, is positive 45 and 2. Then I've got 135 and 1, 225 and 2. And then my last one would be 315 and 3. So as you can see, I've chosen sort of an appropriate scale for this one here so that it makes it easy for me to plot. And this is my new function here, cos x plus 45 degrees plus 2. And just before we wrap up, I think, yeah, that's what I thought. So now we're just going to go through all those graphs and identify the domain, range, amplitude, and period. So my domain is always going to be all the real numbers for x and y. The range is between minus 1 and 1, unless you have a vertical shift or a vertical stretch, but we're not there yet. Our amplitude is 1, so the distance from the midline to the maximum, or the midline to the minimum. Our period is going to be 360 degrees, the length it takes to complete one cycle. Our maximum value here is 1, and our minimum value is minus 1. So let's do the same thing down here. So we've got our domain, same as above, so minus infinity to positive infinity. Our range is different now because we have a vertical shift. So you can probably see, I mean, our lowest value is now going to be minus 4, and our highest value is now going to be minus 2. What else are we listing? Our amplitude, still the same, we don't have any stretches. Our period, also the same, so 360 degrees or 2 pi radians. And our maximum value is just the highest value of our range. Our minimum value is the lowest value of our range. And our last one, maybe the most exciting, but our domain is the same. Our range is now going to go from 1 to 3. Always making sure you go to that lowest point, so 1 to 3. Then my amplitude, still 1 because I have no stretches. My period is 360 degrees or 2 pi, the length of time it takes to complete one cycle. My max value is 3, and my minimum value is 1. Those are 3 examples of phase shift and vertical translation.